there folks, Mr. G here with another educational video. This is going to be the last week of videos on trigonometry, and this week we're going to be going over the second of our two major trig laws, the cosine law. If we remember back to last week, one of the things that we learned how to do was solve side-side angle triangles using our sine law. And when we did this, we had to be careful and watch out for the ambiguous case. However, what we're going to find out this week is that not all side-side angle triangles can be solved using the sine law. Take, for example, this triangle. This is one where we can't actually use the sine law to solve it. And that's because we don't have any side angle pairs in the information that we're given. So if we try and use any part of our sine law, we're missing at least one part of each of these fractions, which means we can't solve any equations. So we need to use something else to help us solve this triangle. This is the table you would see on page 299. These are all really the same equation. If we just start with this as our baseline right here, going to this equation right here, all we've done is swap around a and b. To get to our third equation, we swap a and c, and then we also swap the order between a and b here. To get this equation on the other side, all we do is rearrange it algebraically to isolate for cosine of a. Those are the only real differences. When we use cosine law, and we have one angle and two sides, our first step is always to solve for the missing side. In this case, that side is side A, and we want to use this equation right here because it has side A isolated. We want A, not A squared, so we'll take the square root of both sides, and I'll plug in our numbers at the same time. Remember, we're taking a square root, so we need to think about plus or minus. In this case, all our sides are positive, so we're just going to take the positive one here, and this is what we get for our value for A. I'm not rounding here because I'm going to be using this number for future calculations, so don't round it to 2 decimal places just yet. The next step is to solve for one of our missing angles. In particular, we want to solve for the smallest missing angle. The reason we want to solve for the smallest missing angle here is because the smallest angle in a triangle must be less than 90 degrees. And if it's less than 90 degrees, we can avoid the ambiguous case when we're using our law of sines. If you recall, the smallest side is always across from the smallest angle. So we're going to be using our sine law to solve for the angle across from our smallest side. In this case, our smallest side is C, so we're going to be solving for angle C first. Here we have our sine law. We can rearrange for our angle C. We plug in our numbers, and we get our value for our angle C. Here we don't need to worry about our ambiguous case because we solve for the smallest angle, which has to be less than 90 degrees. Our last step is to find our last angle, and since we know the other two, we can just use the fact that all of the angles need to sum up to 180 degrees. So our missing angle, angle B, must be 180 degrees minus 55 minus 23.036, and we get our answer for our angle B. At this point, I haven't rounded any of my answers, so to answer my question, rounded to 2 decimal places, we would get this right here. When we use the cosine law for 2 sides and 1 angle, there is always only one answer. We can also use the cosine law if we know all 3 sides but none of the angles. However, we do have to be careful, because if we are given 3 sides, we might end up with a triangle that is impossible to form. For example, this one right here. If you notice, our side B is bigger than our other 2 sides put together, which we learned before can't form a triangle. Because these 2 sides are too short to touch, even if we lay them flat against our third side, there's no way we could form a triangle where these 2 are at an angle from our side here of 12. So this is not possible. There's no answer for this triangle because it isn't an actual triangle. If we were to use cosine law here, we would try and solve for the angle across from our largest side. Looking back at our table, we would use this equation right here for cos of b, which if we plug in our numbers like this, tells us that cosine of b is equal to 2.575. If you try and plug this into your calculator to find angle b using inverse cosine, you're going to end up with an error. Now this also came up when we were using sine law sometimes, and we would end up with an impossible triangle. The way we could understand this was by looking at a graph of cosine between 0 and 180 degrees, because all of these angles need to be between 0 and 180 degrees. This is what our graph looks like. You'll notice it starts up here at 1, goes down to -1, and goes through all the different values in between. Now, unlike sine law, there's no overlap here, so there's no ambiguous case for cosine law, but all of our values, all of our y values for cosine of x need to be between 0 and 1. If they're bigger or smaller than that, it's not possible. There's no angle that gives us that answer. So it's always between -1 and 1, this value for cosine of b. If it's not, it's an impossible triangle. And there's no ambiguous case because there's no value of y that has 2 different x values that it corresponds to. If we compare this to sine of x, Notice we had a value like here at 30 degrees that gave us a y value of a half, as well as 150 degrees that gave us a y value of 1/2. So if we were told the sine of our angle is equal to a half, there were two different answers. For cosine, that's not the case. If we're told cos is equal to a half, 60 is the only possible angle. Our last example here, this is not an impossible triangle because we see that these two sides add up to 12, which is bigger than our largest side here. So we know this is going to form an actual triangle. Our first step is to find the biggest missing angle that we have in our triangle here, and we're going to use cosine law to do that. The reason we want to find the biggest missing angle is that the other two angles, which we'll solve using sine law, those other two angles must be less than 90 degrees, which again avoids this ambiguous case. So if we want to find the biggest missing angle, it'll be across from our biggest side C. So we want to solve for cosine of angle C, which if we go up to our table on page 299, looks like this. We plug in our numbers. We'll get this value for the cosine of our angle. Using inverse cosine, we can get the angle itself, which is this right here. Again, I'm not rounding because I am going to be using this value in future calculations. Next, we'll use sine law to solve for a missing angle. It doesn't matter which one that we choose, but remember that this missing angle has to be less than 90 degrees. And that's guaranteed because we know that we already found our biggest angle, the other two have to be less than 90 degrees. Since we have a matching pair of angle C and side C, we're going to have to use those. And let's say we solve for angle B first. We rearrange to get this, which tells us that our angle B will be the inverse sine of these once we plug in our values, and we get an angle of 40 degrees. Again, no ambiguous case here because we know it's less than 90. Our last step is to solve for the last angle, and since we know two of the other angles, we can just use the fact that they add up to 180 degrees. Once we have our last angle here, we can round to 2 decimal places and answer our question. And there's our final answer. Again, only one answer in this case. I know this was a bit of a longer video. Stay tuned for the second video where I'm going to do a quick summary of all the different ways we know how to solve triangles using sine law and cosine law. See you then.